One of the most basic things that you need to remember for 13.1 is the less than and greater than symbols. And you learn them in elementary school, but sometimes you have a hard time remembering what they stand for. And you know what? My 6th period students just told me that I smack in my video, so I'm going to try not to do that. And I just caught myself doing it. So thank you, Matthew, and whoever else told me I do that. Okay, so this is a less than video. This is a less than symbol. It looks like that. And if you turn it, I don't know if I can turn this little thing or not. Let's see. Can I rotate it? No. I don't know how to do that. Okay, well, if I turn it a little bit, it looks like an L for less than. Okay, so I can make my less than symbol the L of the word less. Greater can be put on the G right here. Usually we make a G like that, but if you rotate that little part a little bit, there's your greater than sign. So I can say greater like that. Okay, but a new symbol that you're going to see is this one right here. It is, there I did it, didn't I, Matthew? It's this symbol right here, and it's got part of an equal sign on it. The bottom line of the equal sign is underneath the less than symbol. And you would read that as is less than or equal to. And then the greater than symbol with the equal sign underneath it is greater than or equal to. So if you want to use those in real life, you could say like no more than 8 students can be in the office. Okay? So can you have 8? Yeah. So you can have a number that's equal to 8. Can you have 4? Yeah, because that's not more than 8. It's less than 8. So the number of students that can be in the office has to be less than or equal to 8. So in your notes, of course, you have your Cornell style heading. I want you to put these things here. I want you to put these things here. And I want this example right here. The solution of an inequality that you see right here, you solve it the same way you do the equations, where you either add on both sides or you subtract on both sides. So let's solve A in your notes. I want to see this work. So A says y is less than or equal to -3. Okay, so we're supposed to find, it just wants us to graph the solution. That's easy. All you have to do is place, here's your number line, okay? You put a dot like you do on -3, and then it's talking about numbers that are less than or equal to -3. So then you would just draw a line, and then an arrow would mean all those numbers that continue on the number line need to be included. That's what that arrow means. Okay? Look at B. B says 1 is less than M. Okay? If you read it kind of backwards, M are numbers greater than 1. Now, can that be equal to 1? No. They have to be greater than 1. So you wouldn't include the number 1 on a number line. So how do you graph that on a number line? Notice they put a circle here. Okay? When they put a circle on the number 1, that means not 1 exactly. And then they went ahead and drew their line to the right, showing all the numbers that are bigger than 1, but don't include 1, and I'm showing that by putting a circle where the 1 is. Now let's compare that to the line up here. This said y is less than or equal to -3. So could -3 be a part of that? Yeah, it could. And that's why there is a solid circle here. They colored the circle in because 3 could be a number, -3 could be a number that is a solution there. Is -3 equal to 3? Yeah. And then all these numbers are less than 3. Let's look at the reflection. How is x is less than 5 different from x is less than or greater than 5? Okay, you don't have to write this down. In this statement, you can't use 5 as a solution because 5 is not less than 5. So you would not include 5. Here, it says x is less than or equal to 5. So 5 could be a solution because 5 is actually equal to 5. What else could we put there? We could put a 3. 3 is less than 5. We could put a -20. -20 is less than 5. Could we put 18? No. 18 is not less than or equal to 5. Let's look at how you would write an inequality for a real life problem. I don't know, can you hear Miss Moore yelling? It's like super loud over there. Okay, write an inequality that represents the phrase, the sum of 1 and y is greater than or equal to 3. So when you see the word sum of 1 and y, that means the result of addition, so they added 1 plus y. Okay, and it says is greater than or equal to, that's this symbol here, greater than or equal to 3. Okay, and now they want us to see if 1, if we replace y with 1, is that still true? So I'm going to write the problem again, but this time I'm going to take out the y and I'm going to put a 1. Okay, and they're saying, is that still equal, greater than or equal to 3? Well, what is 1 plus 1, you guys? That's equal to 2. So is this true? 2 is greater than or equal to 3? No, so y equals 1, not a solution. Boo! Write and graph an inequality to represent each situation. It says the highest temperature in February was 6. All right, so that was the highest temperature. That means it was the warmest that it got. That's the greatest temperature. So the other temperatures in February, were they over on the left side or over on the right side? Which side has temperatures that are lower than 6? The temperatures over here. So the way you graph that is you circle that in, or color it in. It's going to be a solid dot because 6 is going to be included on that. And then all these cold temperatures here. We don't know how cold it got, but the warmest was 6. That's pretty cold. I wonder where that was. Okay, number 5. Each package must weigh more than 2 ounces. Do we include 2 ounces on that? Is 2 more than 2? No. So the way we show that, remember, is we start at the 2, but we draw an open circle. That says it's going to be starting at 2, but we can't include 2. And then everything more than that. It's got to weigh more than 2 ounces. Okay? Like even if it was just 2 and a tiny bit over, is that more than 2? Yep, barely.